Let's talk about vitamin B3, also called niacin, because it's one of the most direct dietary connections we have to brain NAD+ levels. This is a nutrient with a clear, well-established biochemical pathway. Your body takes niacin from food and converts it through a series of enzymatic steps into NAD+. It's not speculation. It's basic human metabolism that's been understood for decades. Here's what makes this interesting for brain health. Niacin comes in several forms, and the form you get from whole foods, primarily nicotinic acid and nicotinamide, is what your body naturally processes into NAD+. You find niacin in chicken breast, turkey, tuna, salmon, peanuts, mushrooms, green peas, and fortified grains. These are everyday foods that have been part of human diets forever, and they provide steady, moderate amounts of the vitamin that your body can efficiently convert. The positive case here is straightforward. If brain NAD+ levels decline in Alzheimer's, and if niacin is a direct precursor to NAD+, then ensuring adequate niacin intake through diet makes metabolic sense. It's providing the raw material the brain needs to maintain its energy currency. For older adults especially, who often have declining NAD+ levels even without dementia, eating niacin-rich foods regularly could help support baseline brain metabolism. But we need to be very clear about limitations and warnings. Food-based niacin is not the same as high-dose niacin supplements, and this distinction matters enormously. When you eat a serving of chicken or peanuts, you're getting perhaps 10 to 20 milligrams of niacin. That's enough to meet daily requirements and support normal NAD+ synthesis without overwhelming the body's regulatory mechanisms. High-dose niacin supplements, by contrast, can deliver hundreds or even thousands of milligrams. And here's where things get complicated and potentially dangerous. At very high doses, niacin can cause uncomfortable flushing, liver problems, and changes in blood sugar regulation. More concerning, artificially pushing NAD+ levels too high might promote unwanted cell growth or interfere with normal cellular aging processes. Recent research has raised red flags about indiscriminate NAD+ boosting, particularly with synthetic precursors. Food-based niacin avoids these problems because it provides self-limiting amounts. You'd have to eat impractical quantities of chicken or peanuts to approach supplement-level doses. This natural moderation is actually a safety feature. The body evolved to handle dietary niacin efficiently without excessive NAD+ accumulation. There's another important reality check. Just because niacin converts to NAD+ doesn't mean that eating more niacin-rich foods will automatically prevent or reverse Alzheimer's. The brain's energy problems in Alzheimer's are multifactorial. Neurons might have trouble utilizing NAD+ even when it's available. Other bottlenecks in energy metabolism might limit the benefit. And again, once significant neuronal death has occurred, NAD+ precursors can't resurrect dead cells. What we can say with reasonable confidence is this: ensuring adequate niacin intake through whole foods is a safe, sensible nutritional strategy for supporting brain metabolism as part of overall healthy aging. It won't work miracles, but it provides the building blocks for a critical energy molecule without the risks associated with megadose supplementation. For practical purposes, include a variety of niacin-rich foods regularly: poultry, fish, legumes, nuts, and whole grains. This isn't about obsessing over milligram counts. It's about maintaining dietary patterns that support basic metabolic needs. Think of it as metabolic maintenance rather than metabolic rescue.